All right, everyone. So what we're going to be looking at to end our section on what our electrons are doing within our atom is we've been spending a lot of time using the periodic table, right? Using the periodic table to figure out our configurations, our long and our short, labeling the S, the P, the D, and the F blocks. But what we need to do now is just take a little bit more in-depth look at the periodic table, at some more information that it can tell us, and basically how it's organized. So a brief little history of the periodic table, right? Our periodic table is currently arranged in order of increasing atomic number with elements of similar properties grouped together, okay? And that's what we're gonna look at. One of the vocabulary terms we're gonna see today is this idea of a group or a family and what that means in terms of chemical and physical properties. So our current periodic table, or not actually our current periodic table, the original periodic table was developed in 1869 by a man named Dmitry Mendeleev. Okay, and basically what he did is he put each element that was known at the time on a card. So think of it like an index card. And then he kind of laid them all over his floor or table and tried to arrange them in a way that made sense. And what we saw is that there were elements that had similar properties to one another. So he thought, well, if all of these elements don't react with anything, they should be grouped together. And if all of these elements over here explode in water, they should be grouped together. We have precious metals grouped together. And so he started to organize them that way. Now, his original periodic table was ordered in by atomic mass. Okay, in 1869, that's the only way he could order it because remember, atomic number is the proton number, and we did not have that discovered until Rutherford discovered it in 1919. Okay, so once he discovered that, a man named Henry Moseley came along and reordered it by atomic number. But if you really look at the periodic table and you look at the masses, they almost all go in order of increasing atomic mass. There's only 4 elements that flip spots. Okay, so here, just to finish this up, putting them in this order led to the physical and chemical properties of our elements showing a repeating pattern. Okay, here's just an example of our periodic table. Again, it goes in order of increasing atomic number. That's this number right here, number of protons and number of electrons for a neutral atom. Okay. Here's some other examples of a periodic table. So this is a periodic table that uses kind of like a picture to represent a use, right? So here's fluorine. We see that we have toothpaste because fluorine as an ion is fluoride, which is in toothpaste. Nitrogen, we have some dynamite or TNT, trinitrotoluene. So nitrogen is a component here. Carbon, we have a diamond ring. One of carbon's forms is actually diamonds. We have graphite, charcoal, and diamonds. And then we have, our radioactive elements at the bottom. Here's another one. This is the periodic table of the internet. It's a really old periodic table of the internet because if you look, there is, they're grouped by what the use of the website is. So here, these are search engines. So it does have Google. It includes Yahoo. There's one with social media, like social networking. That's group 14. So if you go to group 14, we do have Facebook on there, which most of you don't use anyway, but like MySpace and LiveJournal, those are relatively old. Those are like even before me, so real old. Here is just a periodic table. It has our atomic numbers and our atomic symbols. Someone just put a Final Fantasy character with each of our elements. Okay, this is one of my grad school periodic tables. So if you start at the center and swirl your way out, you actually do go in order of increasing atomic number. Then when you hit the D block, that's when it juts over here. And when you hit the F block at the bottom, it juts over here. And they are color-coded based on groups and types of elements. Okay, this is just a galaxy version. Okay, this is another one of mine from grad school. This was for energy levels. This is technically an energy level diagram for electron configurations. Okay, someone made a quilt out of one. Okay, and this is another galaxy one. Okay, so how exactly is our periodic table arranged? Okay, so elements in a column are either called groups or families. They're called groups if we number them. So if you look at the periodic table, you go straight across, 1 through 18, those are groups. They're families when we look at their properties. So we have the alkaline earth metal family, which is group 1 on the periodic table. We have the noble gas family, which is group 18. So again, their family is when we look at the properties. Okay, so normally we label groups 1 through 18. There is another system of labeling. I put it on here just so we see it. We won't tackle this one at all until unit 3, where we're only going to use the A's. Okay, groups have similar physical and chemical properties. And then elements in a row are called a period. Okay, so columns are groups, rows are period.
Okay, so just so we're able to see this, we want to be careful about our labeling. So again, when we're talking about columns, we're talking about 1 through 18 here. So 1, 2, 3, 4, all the way through 18. So our noble gases are going to be group 18. And then our periods are these numbers for our rows that we used for our energy levels and electron configurations. So for example, magnesium is in group 2, period 3. So it's kind of like you match it up. Another example would be nitrogen is in group 15, but it's also in period 2. We want to make sure we don't forget helium as our first row number.
Great, and then we look at our types of elements. So elements on the left and in the middle are metals, right? Except for hydrogen. Hydrogen is all the way on the left. It says 1 electron, but it is definitely not a metal. Okay, and some properties we look at with metals. Metals are malleable. I can take a metal, bend it, and twist it around without it breaking. Ductile. They can be stretched into thin wires. Okay, lustrous. So most of them you would describe as shiny. It means they're reflecting light, which means they're lustrous. And they are good conductors of heat and electricity. Now, side note, you do not have to have all 4 of these to be considered a metal. Like aluminum is very malleable, but it's not ductile. Okay? It's lustrous and it's a good conductor of heat and electricity. That's why it heats up so quickly. Okay? But it's not ductile. So to be a metal, you have to have the bulk of these properties. Okay? And then metals are all solid except for mercury. Remember, mercury is our only liquid metal.
All right, so what I've done here is I just want to be able to show you where the different types of elements are in the periodic table. So what I've done so far is I've color-coded the metals green. So we can see that, we ignore hydrogen up here, that all of these are considered metals, okay, including our F block at the bottom. So it's literally almost our entire periodic table is considered a metal.
Okay, within our metals, we have 3 just named groups that we have to be aware of. Group 1 are our alkali metal family. Group 2 is our alkaline earth metal family. And groups 3 through 12 are our transition metals. All right, so here we have a different color-coded periodic table. And so what we're looking at now are these families, okay? So group 1, what I've done is highlighted them in pink. These are our alkali metals, okay? Our alkali metal family. Group 2, which I've colored in yellow, are our alkaline earth metal family. Okay, purple here, our D block, that's our transition metals. And then all the way down at the bottom here, this is the F block of the periodic table. Those are our inner transition metals. Okay, so again, we're just color coding based on families. Our D block. Okay. Then we shift to the right. These are our nonmetals, and we look at some of their physical properties, and we're just going to flip the metallic ones. So if I try to bend these, they're going to break. So they're brittle. Okay, they don't reflect light, so we would call them dull, and they're poor conductors of heat and electricity. Right? The other thing that's different about them is they exist in all 3 states. Okay, most of them are actually gases. All the halogens are gases, except for bromine. Bromine is the only other liquid on the periodic table. The noble gases are gases, obviously, but things like carbon, phosphorus, sulfur, those are solids. All right, so here we can see, again, I color-coded the nonmetals on the right side of our periodic table to be purple. So I just wanted you to have a visual of those. Okay, within our nonmetals, we have a lot of groups that would be considered nonmetal groups, but we're just going to worry about the names of 2 families. Group 17 are our halogens, that's fluorine, chlorine, bromine, and iodine. And then group 18 are our noble gases, which we worked with in our configurations, helium, neon, argon, krypton, xenon, and radon. Okay. And here we finish color coding our families that we're labeling. So we have our light blue halogens right here and our brown noble gases. So this is our total color coded based on named families that I would like you to know. Okay, and our last group that we need to be aware of are our metalloids. So these are elements that have properties of both. Okay, and an example would be silicon. So we're going to use that as our example. Silicon is brittle. If I try to bend it, it will break. Okay, but it's very lustrous. It's actually beautiful. It's one of my favorite elements to look at. But it's a poor conductor of heat and electricity, which is good because if you think about it, we use silicon in like chips, in like cell phones and computers. So we don't want it to overheat. Otherwise, every time you turn on your device, you would fry it. Okay. Other metalloids include boron, silicon, germanium, antimony, and tellurium, okay, and arsenic. Okay, so here is just a picture of the periodic table that's kind of broken apart metals, nonmetals, metalloids as a review, okay, and that is it.